The Raft algorithm makes a collection of machines which are unreliable together to be a super reliable collection of machines, as if it's a single one. It is solving the consensus problem, just like the Paxos. However, when the Raft algorithm was created to resolve the consensus problem, it took a lesson from the Paxos and tried to make itself as simple and as intuitive as possible. It has been shown by many cases that if you try to study the Paxos, it would be very hard. In fact, it was actually shown that if you study Paxos before you study Raft, then studying consensus algorithm could be even more difficult and you would get less of a grade. However, the Raft algorithm was created with understandability in mind. And with that, we begin exploring what is exactly the Raft algorithm and how does it work. Here are the basic building blocks of Raft. First, the name. The name can mean a few things, but the best for you to remember is that a raft is a collection of logs that you could use to sail the sea. And this is exactly the Raft algorithm. It's a collection of replicated logs that the leader replicates to the other servers. And then with these logs, you can know what is the current value, because each replicated logs denotes the set of values that you have set over time. So the building blocks of Raft is simply a log file that you write one value after another, and you replicate these log files into the other servers, which are the non-leader. You have a leader server, you have a majority, and in order to be sure that you get the correct value, you need to have a majority. So there are like two modes of operation in Raft. The first mode is leader election. You need to state who is the leader, where all the commands, the write requests would go to. Also, the leader has the correct log file, which is replicated to the other server. So we have two modes, the leader election, and once we have a leader, then we start receiving commands and replicating the commands into the logs of the other servers. The leader replicates the log file with a list of commands. So let's say we have the leader, then we receive a command to set the value of x to 1. Leader received it, and then it replicates it to the logs of the other. It's first writing it as the first entry into its log file, and it spreads it to the other servers to write it to the log file. Leader now receives that the current value is -1. So it adds after 1, the value -1, it adds it to its local log file and replicates it to all the other log files. Raft also makes sure for consistency and for safety. So when the log file is replicated and when the leader is elected, then it makes sure that it's correct. And we will discuss exactly how this happens. So let's begin when the cluster starts up. So we have a cluster of, let's say, 5 nodes and it starts up. They have no leader at the beginning because we have no leader. No one was elected yet. The basic concept of Raft is that they have timers. Each server has a timer with a random value. So imagine that we take like random values like up to 200 milliseconds, and each server would get a different timer. So the first, and they all start. Okay, the cluster started. We have one server with 20 milliseconds, another server with 50 milliseconds, and so forth. The timer starts. No leader. When the first timer hits 0, then it's casting a vote for itself to be a leader, and it's also sending messages that it's asking for votes from the other nodes. So the other nodes would either vote for him, but if they noticed somehow that its log file is not that consistent or not correct, they would not vote for it. So in this case, we had the cluster starting up, we have the timers all hitting and starting to count down. The first one that counts down to 0 casts a vote to itself, and it's asking to be a leader. Raft also makes sure for consistency and for safety. So when the log file is replicated and when the leader is elected, then it makes sure that it's correct. And we will discuss exactly how this happens. So let's begin when the cluster starts up. So we have a cluster of, let's say, 5 nodes and it starts up. They have no leader at the beginning because we have no leader. No one was elected yet. The basic concept of Raft is that they have timers. Each server has a timer with a random value. So imagine that we take like random values like up to 200 milliseconds, and each server would get a different timer. So the first and they all start. Okay, the cluster started. We have one server with 20 milliseconds, another server with 50 milliseconds, and so forth. The timer starts. No leader. When the first timer hits 0, then it's casting a vote for itself to be a leader, and it's also sending messages that it's asking for votes from the other nodes. So the other nodes would either vote for him, but if they noticed somehow that its log file is not that consistent or not correct, they would not vote for it. So in this case, we had the cluster starting up, we have the timers all hitting and starting to count down. The first one that counts down to 0 casts a vote to itself, and it's asking to be a leader. Once the leader receives a new message for a new value in them, then it would replicate it to the other followers. If a majority of the servers has received this new value, then the server would decide, the leader would decide that this value is actually committed. And the leader would tell all the followers that all their entries up to this one are actually committed. Now, a little bit about the edge cases. What happens if you are a follower and you receive a message to a new entry in your log file, in your replicated log from the leader, and you see that there is inconsistency? How would you know that there is inconsistency? Well, actually, when the server, the leader, sends you a message, then it does not only send you a message of the latest value, but also of the previous value. So you compare the current entry with the previous entry, and if they don't match, then the server, the leader, would send you not only the previous entry, but also the one before it. So it's like a proof by induction. You start with the current value and the previous value. If they don't match, you send also the prev value, and if they don't match, you send also as the leader the prev value until everything matches. And this is how we resolve inconsistencies in the log replication. So we have a collection of servers and a collection of logs. Remember, it's a Raft. A Raft is a collection of logs that you can use to sell and decide on a value. The replicated state machine means also that each of the servers has a state machine. It's actually a collection of servers that compute identical copies of the same state. They have the state. And the way for them to ensure that they have the same state is by running the replicated log file. So the replicated state is like the replicated log file which is run. The log entries only flow from the leader to the other servers. This makes it very simple to manage the replicated logs and makes also the Raft algorithm very easier to understand. The leader sends heartbeat. The heartbeat are very essential to the consensus algorithm so that the followers know that the leader still exists. The Raft uses randomized timers, and they stressed they considered multiple ways to do this, but they decided on the randomized timers because it made the whole process much simpler in order to elect the new leader. This has helped to resolve conflicts simply and rapidly. This means that in most cases, like in really most cases, it would be very, very easy to select the leader because it would be like the first timer. The first timer that would get to zero would actually get elected as the leader. And if not, another timer would go to zero and it would get elected. So it's pretty fast. All this log replication and the election of the leader and the strong leader, which means that the log flow only from the leader to the other servers, to the followers, means that our consensus algorithm is safe and it's proofable. It means that it would never return an incorrect value in any condition, even if there are network delays, partitioning, or packet losses, or duplication or reorder, except for Byzantine fault tolerance, which we do not discuss now. Just in one sentence, Byzantine fault tolerance means that the servers are misbehaving like intentionally, that they are sending the wrong values intentionally. Okay, this is a much harder problem. The system is available and fully functional. We just need a majority of the servers to be available. And it is not affected by a minority of slow nodes. When the leader fails, then we simply elect a new leader. And the leader always takes the operations from the clients. The clients are always sending the new values to the leader, and it is replicating it via the log replication into the clients. It's possible only to elect one leader. The leader is only appending values and it is not overriding values. And as we said, the process starts up with a simple startup of the cluster. When the cluster starts up, we have like an leader election because there is no leader, because one of the timers would go to zero. Remember, we said that we have timer on each server. Once it goes from to zero, then the server that its timer went to zero would try to get elected. It would send a vote to itself and ask the cluster to cast a vote to him. Once it gets a majority, then it is elected as the new server, and then there is like a term 1, term 2, term 3, just like we have terms for actual presidents in the United States. So we have a process of an election, we have term 1, we have the leader, and then maybe it fails. So we have the term 2. To wrap up, we said that the Raft algorithm is composed out of three sub-problems because they have treated it as a standard computer science problem where you divide it into sub-problems and then solve each one. It's like a function for each problem. This is part of trying to make it more understandable. So we have the first part, which is the leader election, the second sub-problem, which is the log replication, and the third sub-problem, which is safety. The leader election simply means that when the timer goes to 0 on a server because it didn't receive the heartbeat or the cluster was started, then we need to elect the leader. This is the leader election submodule. The log replication simply means that we keep the logs in sync with the logs of the leader. And the safety means that once a value has been committed, and committed means it was approved by majority of the servers, then this is the actual correct value. And each server can exist in one of three states: a leader, a follower, or a candidate. In most normal operations, it is a leader or a follower. Each candidate can receive votes from the majority of the servers. When it receives actual votes from the majority of the servers, then it becomes the actual leaders. And the log is being continuously replicated. Okay, so the log is what the client has said. The client said, I want the value to be 1, I want the value to be 2, and then this log is being replicated to the clients. The leader maintains the next index for each follower, such that whenever it's sending a new entry to add to the log file to each follower, it also sends the previous entry, such that if the client notices, if we notice that they do not match, then we go one step backward, and this is our way to ensure the safety. Also, the Raft determines which of two logs is more up to date by comparing the index and the term of the last entries of the logs. If the logs that have been committed have entries with different terms than the log with the later term, the term means like the term of the presidency. Okay, so the term of Trump is later than the term of Obama. If the logs end with the same term, then whichever log is longer is up to date. The joint consensus allow individual servers to transition between configurations at different times without compromising on safety. Furthermore, joint consensus allows the cluster to continue servicing clients through the configuration changes. And this was basically the Raft algorithm. It consists of three submodules: the leader elections. All client actions go to the leader replicates its log to the followers. The followers all have timers. They received heartbeat from the Raft leader. If they don't receive a heartbeat, then they try to elect a new leader. And once we replicate the log, we make sure that the log that we have replicated to is in sync, which means we do it like by induction. So I think this was pretty interesting. This was an introduction to the Raft algorithm, and I will see you next time. In fact, the Raft algorithm was not only created with the understandability in mind, but also with the implementation in mind. Because in the standard Paxos paper, it is solving the problem of deciding on one value for eternity, and deciding on multiple values on one after another is called multi-Paxos. So the Raft is as efficient as the Paxos algorithm, but with a different structure that is meant to be understandable by different people. The Paxos has dominated the discussion of the consensus problem for the recent 25 years. But the problem is that it was not only complex, but it was not designed with understandability in mind. It's a brilliant and a genius algorithm, but it takes a lot of hard time to understand it. And so papers with created like Paxos made easy, and then there was paper Paxos made complex. And also it's not solving like the whole ecosystem. It's more like of a pure computer scientist paper than an implementation wise. So both are solving the consensus problem, and the consensus problem are simply for deciding on a value. You have a set of machines, you give them a value and you want to get that value back. And when you when you set a new value, then you want to get that new value and not a different value. This is the consensus. It's like a bunch of states in the United States are deciding on the president, and he is the president. As of now, it's Donald Trump. And now when you ask them who is the president, they say Donald Trump, and they don't say Obama, because Trump is actually the president and not Obama. If there was a failure on one of the machines, then you also expect to get the correct answer and not a different one.